All right, so in front of you, you will have a copy of the angle theorems for triangles notes. And say thank you to the Trinity Springs Middle School office aides. They were so helpful in helping us get all of these folded. So if you're in our class, thank you even more. So when you flip this open, you will see the first page at the top. All of this is going to be under the vocabulary tab, and we're going to talk about 3 different types of angles, and the first one is interior angles. So interior angles are those that are on the inside of the triangles, and if you think about an interior decorator, that's somebody that is going to decorate the inside of the house. And these, and you can go ahead and mark along, are going to fall on these angles here. These are what would distinguish a interior angle. An exterior angle is maybe what you're thinking, just on the outside. So when you exit something, you go outside. So the exterior angles are going to be on the outside like this, and you can go ahead and mark those along with me. And this last one says remote interior angles. And maybe you're thinking, I have no idea what you're talking about, Miss Walton. But that's why we're here. So a remote interior angle is the 2 angles right here. And Mr. Campbell talked about how when you have a remote for a TV or something of that nature, you're wanting to use it to access something that is out of your initial reach. So this remote interior angle is going to be the 2 angles that are furthest away from this angle right here. All right. Give you a second to write those down. And then on this same page, I'm just going to, you'll be moving down the page. I'm going to swipe across. And now on the inside and outside of this triangle, we see some numbers. So when you have numbers in these triangles, these are going to be the labels for the different angles. So the interior, being the angles on the inside, we're going to see something that looks like this. And this sign right here represents an angle. So you'll see this a lot throughout this portion of our math class and further on. So this represents angle. So we have angle 1. I'm going to go ahead and so we have angle 1 right there, angle 1 right here. So then we're going to move down and angle, it's kind of like a sideways V or a less than sign, however you want to think about it. Angle 2, also an interior angle. And then last but not least, we have angle 3. So that covers our interior angles. So remember that little less than sign is not a less than sign, but it represents angled, like we've had different signs that represent different things. For example, if you had a 90 degrees, this indicates 90 degrees. Even though it doesn't say 90, we know that it means 90 degrees. So this angle sign means angle even though it doesn't say the word angle. And our exterior angles are going to be the angles on the outside. We're going to exit the triangle to find our exterior angles. And that one is with angle number 4. So that one's taking care of that one. So we have another blank, and there was one more word, and it was remote interior angles. So let's go ahead and find those remote interior angles. So we said that when you use a remote, it is to access something that's furthest away. So if we're trying to access this thing that's the thing that's furthest away, we're going to use angle 1 and angle 2. So angle 1 and angle 2 are remote interior angles to the furthest away would be angle 4. So just remember, these are the ones that are being accessed for different purposes. And that will take care of our vocabulary. And give you a second to write this. And then when you're going to flip up your paper, and you will see a thing. The sentence on the top will say, the triangle sum theorem states that for triangle ABC. So you may be thinking, how do I know that this is triangle ABC? So on this previous page, they were using numbers to represent different angles. And on this triangle, they're using letters to represent a specific triangle. So they can use numbers, they can use letters, they kind of get to do what they want. So in this the triangle sum theorem states that for triangle, and I'm saying triangle because there's my triangle there, triangle ABC, so A, B, and C. Triangle ABC, we have the measure of angle 1. Okay, I realize I just wrote an M and I said measure, and I haven't talked about that yet. So how we talked about how this can represent the word angle. So rather than having to write angle every single time, they have a shortcut for you. And the same with the M is going to be short for measure. So it's just a shorthand. It's kind of like saying LOL or JK or TTYL. And you can use the letter M and the angle sign to say the measure of angle, the measure of angle 1, 2, 3, etc. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, since there are 3 angles in a triangle, these are all going to add up to equal the magic number of 180 degrees. So we have some practice problems, and our goal here is to find the measure of each angle. And I know that we've done some practice, but more practice never hurts. So I'm going to go ahead and zoom in on practice problem number 1. Find the measure of each angle. So this triangle, the other triangle was triangle ABC, but this one looks like we have triangle X, Y, Z. And they usually like to pick letters that are after one another, so it's more convenient. So if they told us in the triangle sum theorem that the measure of the three angles have to equal 180, we can then add up our different angles, 77 plus 54. And then we have one unknown, so I'm going to use X as my variable. A variable is a letter represented by an unknown. An unknown represented by a letter, sorry. And when I go ahead and do this, I will, and you're going to want to go ahead and write these examples down with me. So when we're looking at an equation, we're going to want to combine our like terms without changing any signs. So in this equation here, we have some like terms. I'm going to circle my constants and box my variables so I can see where my like terms are. Here's my constants, and I'm going to box my variables there, kind of like we did in the word problems. So I see that on the right side we have 77 and 54 that are like terms, and when we add these together, we're going to have 131 plus x, since there's no other x's, and that's going to equal 180. And then from here, as we see that there aren't variables on both sides, we can go to step 3, which is to see if we have constants, and we do. So we're going to have to do the inverse operation of 131, a positive, and this will become 0, and 180 minus 131 is, give you some time to think, this will become 7, this will become 10, 10 minus 1 is 9, 7 minus 3 is 4, and 1 minus 1 is 0. And we are left only with a positive x. And since there's no coefficient, our final answer is here. So we know that this angle is 49 degrees. All right. So here's our next problem. And we have another way of solving an equation. I'm going to give another example. So on this one, we set it all equal to 180, which is still correct. I want to, maybe in the past yesterday, you would have, when you saw these, you thought, okay, I'm going to take my interior angles of 115, and I'm going to add that to 26. And then when I add this up, I'm going to get 11, 2 and 2 is 4, 141. And I know that this has to equal 180, so I know that I could subtract 141 from this, and so it becomes 7, 10 minus 1 is 9, 7 minus 4 is 3, and we'll be left with 39 degrees. So there's two ways that you could look at this, depending on what information they give you. So I'm going to continue to solve them like number 1 because I think it will help us in the long run. So moving to example number 3, go ahead and give us some space. Number 3, so we have triangle STU, and we know that these have to add up together and equal 180 degrees. So, since we only have variables, we're going to have to take our interior information, 7x plus 4x plus 5 plus 6x plus 5. And then I'm going to have to do the same thing I did with the other one, except the variables just look a little different. So we have a variable, and I'm circling. Hold on. We're boxing our variables, and circling our constants. So we're going to go ahead and combine the ones on the right that we can. So 7x plus 4x plus 6x is going to be 17x. And then we have 5 plus 5, which is 10. And this equals 180. So from here, it's a lot cleaner. We have a positive 10 and a 17x, and since we don't have variables on both sides, we're going to have to isolate the 17x, and we can do that by the inverse operation of positive 10, which is to subtract, and we'll be left with 170, and we still have our 17x. And then our last step is to divide both sides by our coefficient of 17, and we will be left with 170 divided by 17, which is 10. All right. Give you a second to write that one. And I'm going to go ahead and just erase this side so that when I move over, I'll have some space for this one. So problem number 4, we have triangle JKL. So triangle J, K, and L. And once again, 180 degrees is our magic number. So the total of our interior angles has to equal 180 degrees. So we're going to take the angles with variables that they've given us, and we're going to add them up. So we're going to take 26x plus 12x plus 2 plus 6x plus 2. Okay, I'm going to go ahead and circle my constants. We have another 2, positive 2, and box our variables. We have 26x, 12x, and 6x. So when we go to solve this equation, our first step is to combine like terms without changing any signs. And this will add up to 26 plus 12 plus 6 will be 44x, and 2 plus 2 is 4. And since 180 is all alone over here, we just have 180. So once again, we need to get this 44x by itself, and so we can do our inverse operation of positive 4. This will become 0, and this will become 176 equals 44x. And we're not quite done because our coefficient needs to be a 1, but it's not yet. So to make that one, we will divide both sides by 44. And our final answer will be 4. Okay. And something that I would like now to go back. So on this one, I'm going to go ahead and erase all of the work, but I'm going to leave my x equals 4. And I'm going to do the same thing on this triangle as well. So I'm going to leave our answer x equals 10 because they asked us, we need to find not x, but they want to find the measure of the angles. So in order to do that, we can substitute our x's back into our problem. So going back to number 3, you'll have some more space at the bottom of your page. So the measure of angle S, so here's S, so the measure of angle S equals 7x. But now we know that x equals 10, so we can take the measure of angle S and substitute, right here, we can substitute 10 for x. So when we take 7 and multiply it by 10, we get 70 degrees. So now we want to do that with measure of angle T, which is 4, and then remember we have 10 plus 5. So we have the measure of angle T is 40 plus 5. So the measure of angle T equals 45. And last but not least, we have the measure of angle U. So this one says 6. Remember, we can substitute our 10 for our x plus 5. And so this will equal 60 plus 5 is 65. So all of these have our degree symbol here. So going over, so now on problem 4, at the bottom there should be enough space for you to write the measure of angle J, which is 12, and then we have our 4 here. So we'll substitute our 4 into, for x plus 2, this will equal 12 times 4 is 12 times 4 is 48 plus 2 equals 50 degrees. The measure of angle K is 26 times 4, which will be 104 degrees. And the measure of angle L, 6 times 4 plus 2, which is 24 plus 2, 26 times 4 is 24, plus 2 is 26 degrees. So there we go on that one. And these are all under the category of the triangle sum theorem. All right, and when you look at the bottom, when you flip open again, you're going to have a really long page that starts with the exterior angle theorem. So I'm going to go ahead and read through this. The exterior angle theorem states that the measure of an, fill in the blank, exterior angle, I feel like I'm playing hangman, exterior angle is equal to the sum of its remote interior angle. Okay, so it says the exterior angle theorem states that the measure of an exterior angle, so an outside of the triangle angle, is equal to the sum of its remote interior angles. Okay, So this would mean that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. So remember, these angle 1 and 2, those are the furthest away. That's where you're using your remote, right? To access the furthest angle, which is angle 4 on the outside of the triangle. And so here, let's have some practice. Okay. So the measure, this says to find the measure of each angle. Okay. So this triangle is triangle A, B, C. But they're asking us here to find the measure of angle ACB. So when you're counting, when you're being asked to find a certain angle, you're saying, well, why didn't they just ask us for a measure of angle A or the measure of angle B? So they are, just kind of in a secret way. So they like to tell us the angle they're trying to find is always going to be the middle letter. And as you look at this one right above, the one that's missing is in the C. So they just read it, the measure of angle A, C, B. So that middle letter, C, is our missing angle. So we can find this by remembering that the total interior of the angles has to equal 180. So if we add 58 plus 74, we get 132. 58 plus 74, this equals 132. So it has to equal 180, so we can take 180 and subtract 132 in order to get our other angle. So this one we find is going to be, so the measure of angle ACB equals 48 degrees. Okay, so we knew that one from the triangle sum theorem. But this one, it says the exterior angle theorem. So again, it's saying that the exterior angle states that the measure of an exterior angle is equal to the sum of its remote interior angle. So the measure of angle, so here, the measure of angle BCD, so once again, we're looking for this here, the measure of angle BCD is, like they said here, the sum of its remote interior angle. So our remote interior angle, these ones would represent, when you add those together, which we already did to find the measure of angle ACB, was 132 degrees. So, again, here we have triangle F. So we have triangle FGH. Just checking my alphabet. And so we know that the sum of the exterior, the exterior angle states that the measure of an exterior angle, so the exterior angle right here, so the measure of that is equal to the sum of its remote interior angles. So this sum right here is going to equal the sum of 103 and 51. So 103 plus 51 is going to equal 154 degrees. And then I thought it was easier to find that one first. So then we can take 180 and subtract it from our 154 to find the measure of angle F, start 1, H, G. So this is our missing angle, which we find is 26 degrees when we subtract them. All right. And our last two examples, take a deep breath and we can get through it. So we're doing the same thing. Don't just shut down because you see some variables. So on this one, we are given the sum of our exterior. We're given the exterior angle, the exterior angle here. So if they told us that the sum of the exterior angle is equal to the sum of its remote interior angles, remember remote, furthest away, so that means we can use our exterior angle and set it equal to the sum of our remote interior angles. So from there, once again, we have our variables and our constants. So we can combine the 18x and the 15x, which will give us 33x plus 3 equals 135. And then here we go, subtract 3. We have 132 equals 33x, and then divide, and our final is x equals 4. Okay, so now they're asking us for a couple of blanks, which represent the measure of angle R, the measure of angle S, and the measure of RQS. So which one are they asking for? Measure of RQS. So the middle, remember that's they're hiding that, the measure of angle RQS, which we can then substitute our 4. We can substitute our 4 into our problem. So take 18 times 4, which will give us 72 degrees. And then we have 15 times 4 plus 3, which will give us the measure of angle S, which is 63 degrees. And last but not least, we have the measure of RQS, which we know has to be what's remaining after we add angle R and S up from 180. So 180, so 70. So we know that it equals 135, so we can subtract 180. We can subtract 135 from 180. All right. So this will become 7, 10, 5. 7 minus 3 is 4, and we have 45 degrees. And I just thought, make sure to write your degrees pretty small so that they don't get confused for zeros. All right, last problem. So just like we did on the other one, we have 100 as our exterior angle, and that is going to equal the sum of our remote interior angles. So angle J, and angle K are our remote interior angles. Our remote interior angles. So those are going to 7x plus 4 plus 9x. And go ahead and box my variables and circle my constants so we can combine 7 and 9, 7x and 9x because they are like terms, and we will get 16x plus 4, and we still have our lonely 100 over there. But it's not going to be lonely once we subtract 4 from each side. This will become 0. We'll have 96 equals 16x. And our last step is to, hopefully someone in my class will say, and Mr. Campbell's class, say to divide by our coefficient of 16. This will become 1, and we will have our final of x equals 96 divided by 16, which is 6. So we're not quite done. We have to just look at the measure of angle J. Find the measure of angle J, the measure of K, and the measure of angle JKL. So again, that middle JLK. And as we substitute, 7 times 6 plus 4, 9 times 6 for K, and we know this is 7 times 6 is 42. 42 plus 4 is 46 degrees. 9 times 6 is 54. So when we add those up, we get 100. And so if we get a 100 on the inside and it has to be 180, we can take 180 and subtract 100, and we get the total of 80 degrees. All right, thanks for watching, guys, and have a good day.